The work I am presenting is on our adaptation of heuristic evaluation for virtual reality systems for visualization of robot sensor data in nuclear decommissioning. One of the problems in nuclear decommissioning is that many of the sites were built and reached the end of their operational use some time ago. Therefore, information about what is inside those sites is limited and therefore require an exploration, mapping and characterization procedure to be followed before decommissioning can commence. Our proposed solution to this characterization challenge is the use of a teleoperated multi-robot system which gathers sensor data and about the environmental conditions in the sites to be decommissioned. This generates a large amount of data which needs to be understood and operated upon in an intuitive manner, and we are investigating VR as a solution to this issue. How to design and evaluate such systems to meet the operational needs of the nuclear decommissioning industry is an open question. We have investigated using heuristic evaluation as an initial evaluation methodology to generate design requirements prior to larger scale, more expensive user studies. Heuristic evaluation is a software evaluation methodology proposed in the 90s by Nielsen, where a small number of design experts evaluate how well a system fits a set of design heuristics specifying idealized systems. The procedure that's followed is that initially heuristics are selected from validated lists of heuristics according to system requirements. A task is specified that is analogous to that performed during normal system operation. Expert operators, once they are familiar with the heuristics, then perform the outlined task and provide feedback structured by the heuristics provided according to problems they encountered during task performance. All the feedback they give is ensure that it fits the heuristics correctly, and that fitted data is then used to generate system refinements. This is a low-cost evaluation methodology, both in terms of experimental time and experimental cost, due to the number of participants required is much fewer, because you can perform this with as few as 4 experts. And it's often run prior to full user studies to improve system quality and hence improve the utility of those user studies. Here we propose a means by which heuristic evaluation can be adapted to virtual reality information visualization systems such as the one we have used. To do so, we have selected heuristics from both the virtual reality and information visualization literature, and we have created a list whereby we have removed redundant or unnecessary heuristics in order to get efficient feedback on our system. We have demonstrated the use of our adaptation to heuristic evaluation on our system. The data that is used to generate the virtual reality environment consists of a point cloud, which can either be coloured according to the data from the RGBD camera or from the data from a collimated radiation sensor. Data comprehension utilises a navigation system for moving within the render point cloud environment. The task given to expert operators was to navigate to and then characterise a source of radiation, and while performing the task they gave their feedback verbally. It was then recorded and transcribed, supplemented with a post-task interview, and then fitted by myself to the design heuristics and used to generate system refinements. We found that the set of heuristics we utilised, combined with the modifications we made to heuristic evaluation, made it well suited to our needs. Fitting of feedback to the heuristics facilitated better understanding of the problems that were encountered by the experts and resulted in clear, structured modifications that could be made to move the system closer to the ideals of the heuristics. In addition, we also found insights from the design experts that conducted the heuristic evaluation on modifications that could be made to the system that will require further study, such as using voxels to render the environment rather than points to allow data manipulation as well as easier perception.